Okay, welcome to 14.2 Proportions. Here are a couple vocabulary words that you are going to need before we start our lesson. First, you need to know what a proportion is. A proportion is an equation, that's the big idea, stating that two ratios are equal. Okay, so when you write a proportion, or when we write proportions, what does the word equation mean, or what do all equations have? That's right, they need to have an equal sign. They don't have an equal sign, they're not a proportion, it is just two ratios sitting next to each other. Okay? You're also going to need the vocabulary word proportional, meaning that the ratios are equal. So the purpose of today's lesson is to determine if ratios are proportional, and kind of get familiar with them, okay? So let me give you an example of what a proportion would look like. We can start with any ratio, so 5 to 7. And remember, a proportion means the ratios are equivalent or equal. So if I just took these two numbers and I doubled them, 10 to 14, though this makes up a proportion. So this whole thing, the two ratios and the equal sign make a proportion, okay? So here would be an example of what a proportion looks like, okay? So the way we would read this, we wouldn't say 5 7s equals 10 14s. Technically, we would read it 5 is to 7 as 10 is to 14. So when we read it, I don't know if you really need to write this part down, but we need to know how to say things correctly. 5 is to 7. This is read as 10 is to 14. Okay? So there's our background information on what proportions are, what it means to be proportional. So let's try it out. So part 1, it's going to give us a set of ratios, and our job is to determine if the two ratios are proportional. Okay, red alert. We've done this before. We've done it with fractions. We have lots of strategies to compare fractions. It is exactly the same. So I guess we'll just talk about a couple of those strategies that we use to compare fractions, and it's the same thing when we compare ratios. We've practiced this already before, so it should be just really a quick review for you. So if I gave you the ratio 1 to 3, and the ratio 7/21, we want to determine if these two ratios are proportional. In other words, could we put an equal sign in between them and make it a proportion? So one way we can do that is to reduce our ratios to simplest form. Okay, so we could say, well, 1 to 3 is already in simplest form. 7/21, well, that actually reduces to 1 to 3. These two ratios are equal, which means yes, they are proportional. So on a test or quiz, you could write your answer as yes, or you could say, yes, they are proportional. Okay? Some of you don't choose to reduce your ratios. Some of you instead want to use cross products to determine if fractions are equal, and we can apply that same strategy here. So our cross products must be equal. So if we took let's just take the same set of ratios, 1 to 3 and 7/21, and we multiplied across. 3 times 7 is 21. There's our product across. And then we multiplied the other way. 21 times 1 is 21. If our cross products are equal, we would still say yes, they're proportional. If they weren't equal, like we had 18 and 21, then we would say no, the ratios are not proportional. Okay, so this part should all be pretty familiar to you. Just practice again, determining if our ratios, our fractions are equal. Okay, so then let's apply it to something that looks a little more complicated, but I think you're gonna be okay with it. Okay, so you're gonna get directions that look like this. Tell if X and Y are proportional. Okay, so and then you're gonna get a table with X values and Y values. So let me just set up the table, you start to copy it. I'll get it set up and then I'll start to explain it. So let's see, our first X value is 1/2 with a Y value of 3. Our second X value is 1 with a Y value of 6. Our next X value is 3/2 with a Y value of 9. And our last set is 2 and 12. Okay, so our job is to tell if X and Y are proportional. So we're gonna do this by comparing each set of X to Y as a ratio in simplest form. Okay, so in other words, we have 1, 2, 3, 4 sets of numbers that you're going to need to compare. So if we want to think of it as putting in our semicolon or our colon here, we have 4 ratios that we have to write, and then we need to make sure all 4 of those ratios are in simplest form. Okay, so I'm just going to number these 1, 2, 3, 4 just to stay organized. Okay, so ratio number 1, we're comparing X to Y. So our X value is 1/2 and our Y value is 3. Okay, our second ratio, we're gonna deal with this complex fraction in a second, is 1 to 6. Our third ratio is 3/2 to 9. And our fourth ratio, if I take it out of the, out of the table, is 2 to 12. Well, we can't compare these because number 1, we have complex fractions, and number 2, some of them aren't in simplest form. So I think for the sake of this question, I'm gonna turn all of these into fractions in simplest form, and then I know if all of those fractions are equal, they're all the same fraction, then those ratios will be proportional, meaning X and Y are proportional. Okay, so let's start with the easy ones first and get those out of the way. So ratio number 2, 1 to 6, is already in simplest form, so no work to do there. Number 4, these can both be divided by 2. So 2/12 is equivalent to 1/6. So far we've only done 2 of them, and we're on the track to x and y being proportional because these are equal, but we have to check to make sure that 1 and 3 also end up as 1/6. Okay, in lesson 14.1, we dealt with getting rid of a fraction within a fraction. Okay, so the easy thing about this one is it only has one fraction to eliminate. So in order to get this 2 to cancel out, we have to multiply by 2. Now be careful, because if we keep this fraction equivalent, whatever we do to the numerator, I should have used a different color. Whatever we do to the numerator, we also have to do to the denominator. Just like we divided both of these by 2, we're gonna multiply these both by 2, okay? Well, 2, let's deal with the numerator first only. 2 is the same as 2 over 1, which is exactly what we want. These 2's will then reduce to 1's. And if I multiply straight across, 1 times 1 is 1, and 1 over 1 is simply, or 1 times 1 is simply 1, okay? So the numerator becomes a 1. Then we're gonna look at the denominator. 3 times 2 is 6. So far, I have 1 over 6, 1 over 6, 1 over 6. So we have that last fraction that we have to change to simplest form. We have to eliminate the denominator, okay? So if you didn't understand how we did it on number 1 here, tune in again. So I want to get rid of the denominator. So in other words, I want this denominator to reduce out to a 1. So I need to multiply by 2, because that's going to allow me, or 2 over 1, that's going to allow me to change these both into 1's, okay? And whatever I do to the numerator of a fraction, I have to do to the denominator. That's how we get equivalent fractions, okay? So I'm going to do the denominator here first. 9 times 2 is 18, okay? And then I'll kind of work this out the long way in case I lost you on the last one. So these 2's I can reduce into 1's. Then I multiply straight across. 3 times 1 is 3. 1 times 1 is 1. And 3 over 1 is the same as just 3. So 3 becomes my numerator, and the denominator, of course, didn't change. Well, 3 over 18 does reduce to 1 over 6. All 4 of these ratios are equal. So x and y are proportional. Okay, that completes 14.2. We'll do the extension in the next digital lesson.